Hello, everybody. Welcome to EarthSky. I'm Deborah Bird. We've got a lot to tell you about today. Not one, but two comets might be bright in the October sky. And there's a meteor shower peaking tonight that might turn into a meteor storm. But first, this news from EarthSky's David Dalian.
Hey, thanks, Debbie. How you guys doing? Good to see you. Welcome. Anyway, what we've got here, what you're looking at now, is a picture of the Hera mission. This is an ESA mission that is going to go and study asteroid Dimorphos and Didymus, which are a pair of asteroids, one larger than the other. And we hit this with DART earlier. It's launching here this morning, just a couple of hours ago, aboard a Falcon 9 out of Florida. And it's going to take 2 years. It's going to get itself up to the asteroid and take a look at the damage that DART did and see how much of an effect we had on it. This is part of a planetary protection program to help us keep the Earth rotating and keep the people alive. The Earth will be fine. It's the people who are in trouble. So this will help protect us in the event that we discover an asteroid. And we've got some other news going on here. If I can just grab the share button out of Debbie's hand. Oh, maybe not. Anyway, we are looking right now at a storm. I believe it's Milton. Let's jump over. There we go. I've been given permission to share. Here we go. We are looking at Hurricane Milton, and Hurricane Milton is currently cruising over the Gulf of Mexico, having, you can see here, it's just brushing along. This is the Yucatan Peninsula. It is going to make landfall about 8 o'clock tomorrow morning on the coast of Florida, the east coast of Florida, somewhere near Tampa Bay, and it's going to take all day long crossing over. You can see that down in the lower right-hand corner. But the important news here is this has just reached Category 5. So we're talking about sustained winds of 155 miles an hour. And it will pick up more energy as it crosses that warm water in the Gulf. So if you're in the path of this thing, get prepared. And that, Debbie, is all I've got. So let's stop sharing that and get on with the show.
Oh, gotta move to the next one. Yeah, the comet. This is so exciting. Hey, Marcy Curran is here with us. Let's bring Dave back because he knows about comets too. Marcy is the EarthSky's voice of the night sky. So, Dave, tell us, pronounce the name of this comet for us. You're the best one at pronouncing.
You would catch me off guard like that.
Oh, sorry.
Hang on. Let me get this absolutely right. It is Shushan. I believe. I have to actually look this up.
We call it Comet A3.
We're calling it A3. It's Shushan A3. I'm heading over to EarthSky, and this is something everybody should do. If you don't know something, go over to EarthSky and check, and you're going to find it. You're going to find your answer right there. I promise. It is Shushan Atlas. It's C/2023 A3, and maybe one of you guys would like to tackle explaining what the numbers there mean. It's the year of discovery. Anyway, you guys try that out.
Yeah, so 2023, let me take a shot at that, and then I want to let Marcy talk about it. So the 2023 means that it was discovered in 2023, and actually they thought that this comet had disintegrated. It was coming in and people got kind of excited about it. Then they thought it was disintegrating and they got kind of negative about it. And then it didn't disintegrate and suddenly it got much brighter. And this is so typical of comets. They just do these strange, weird, they just do whatever they want to do. And so they're very, very unpredictable. But this comet this image is from John Ashley, who is a member of our community, a wonderful photographer. He took this from Tucumcari, Arizona, on September 30th, when the comet was in the morning sky. It was best seen, of course, from the southern hemisphere. So here's an image from October 1st from Australia. And now the comet has gone into the sun. So it got lower and lower and lower and lower in the morning sky. And then it got too close to the sunrise glare to be visible. But we can see it. I'm going to go back actually to this image. Sun observing spacecraft can see it. And this is the stereo spacecraft that caught the comet on October 4th. That thing coming into view on the right there is the comet. And they reported that it looks really bright. So what could happen is, and now I'm going to let Marcy take this over, when it comes into the evening sky, we could have quite a show. What do you think, Marcy?
Well, you know, comets are like meteor showers. You hope for the best and prepare for the worst, right? But hopefully it's been a performer in the morning sky. And once it gets closest to us, which is closest to Earth on October 12th, it'll be moving into the evening sky. And hopefully we'll have a good show and you'll be able to see it with the unaided eye. If not, sweep the area, the western sky with binoculars and use a star app. I recommend that because it's going to show you which direction the tail is pointing. So if it's kind of iffy or in twilight and you're not sure you're seeing it, you can usually see that little faint tail, and it's really helpful to know which direction that tail is going to point from your location to help you locate it.
So it doesn't look like a star, right?
It does not. You're going to see kind of the brightest spots going to be the head of the comet, which is made up of the coma and the nucleus. The nucleus is the basic dirty snowball that makes up the comet. And as it gets near the sun, of course, it starts to like evaporate, and you get the gases coming off the comet, and it makes like a little cloud around the nucleus. That's called the coma. And so basically the head of the comet's always going to be the brightest. And then as the gases are streaming away, there's usually two tails coming off the comet. There's a gas tail and a dust tail. And they're always blowing away from the sun. So it's really, they're amazing to see in a dark sky. So hopefully we get a good show with this.
Awesome. And we have a member of the EarthSky community with us who's waiting backstage right now. He is coming on shortly to tell us about how to take pictures of the comet and to show us some pictures. And the first picture he's going to show us has a comet with two tails, which is kind of cool. So I'll wait for him to tell us about that. But I did want to show one more slide here. Oh, two more slides. And that is that the planet Venus is also in the west after sunset right now. And it's very, very bright. So I don't want anybody looking out there and seeing the planet Venus and saying, it's the comet, I see it. Because Venus is not the comet. Venus is the brightest object that we can see from Earth other than the moon. So it's very, very bright. It's in the west after sunset now. It is not the comet. And notice in this image that is a charge showing October 14th. This was made with the online planetarium software Stellarium, which we really recommend for seeing how things look from your location. And you can see that the comet is close to the horizon here. But then just a couple days later, on October 17th, the comet has moved higher in the sky. So now it's above and to the right of Venus in the west after sunset. So that is coming up, Comet A3, but it's not the only comet that we might see in the October night sky, we have 2 comets. And here's the other one. Which one of you guys wants to tell people about this one? This is a cool one. This is a Sungrazer comet.
This is A1. This is Atlas A1, right? Is that
S1.
S1. I'm sorry, A3 and S1. Good catch. Yeah, and it's green. It's a green comet, which can be sometimes an indication of the composition of the gas. So I don't know. It might be a cyanide bearing one. Nothing to worry about if it comes close. But you know, the color can be an indication of the composition of the core. It's funny that you would call it the head, because the coma is the surrounding gas, and that means hair in Greek. So it's the comet's hair. Anyway, and this is a sungrazer. That means it's going to get very close. Or in fact, it already did it not?
No, it's
Is it
perihelion.
already as close
I
as
think it's October 28th.
perihelion on the
Right.
Okay. All right. And so it is a sungrazer, and all of the great comets of the past have been sungrazers in this class. They may in fact be part of a bigger comet that came apart in the distant past. We're not sure about that. But anyway, all the great comets of the past, it's forever basically, have been members of this class. So we'll see what happens. Fingers crossed. I mean, really, it's impossible to guess what a comet's gonna do. They're just,
especially a sungrazer, because when it goes past the sun, it might not survive.
No, it might not. It could break apart. It could melt, or it could be pulled apart by gravitation, the warping of the body as it, it'll be more gravity on one side. So it'll have a tide, and that tide can be destructive. It can be a destructive tide.
That's right. Or
it depends on,
no, go ahead, Dave.
Oh, it just depends on the composition of the comet and how close it gets. Yes. How much tidal effect, and then how much that effect can affect the material.
Yes. So instead of I'll say, but if it does survive, then it may turn into something like this. And this is Comet Ikea Secchi of 1965. This comet is very similar to what the Comet S1 is like, because it was seen in advance. It was seen that it was going to be a sun-grazing comet. It did go around the sun, and then it became bright enough to be visible near the sun in the daytime sky. And that's the prediction for S1. S1 might become bright enough to be visible in the daytime near the sun.
We haven't had a really good comet
for
about 25, 30 years. Yeah.
Yeah, this was 1965.
Not in the north. And no, when we say that, not in the northern hemisphere. We had a pretty good one in the southern hemisphere, Comet McNaught. Yeah, well, we missed out.
It was visible in the daytime, though, was it?
No, it wasn't.
No, not like this. No, we're not. It's not the same class, but it was a pretty good nighttime show. Had a nice long visible tail. And that's usually, that's what makes it for me. A nice long visible tail streaking across the sky, making it all, those familiar constellations all different,
McNaught had that really unique fanned tail that just kind of spread out as an arc across the sky. It was pretty amazing to see.
It was like a speedboat had ripped through our solar system and just thrown up a big rooster tail as it went.
But it was seen from the southern hemisphere.
Lucky Australians, all those lucky Brazilians.
That's right.
Billions of Brazilians.
Okay, so there's a bunch of us in here, and we have Steve Bellavio waiting backstage to join us and tell us how to take pictures of comets. So Natalia, could you put Marcy and me backstage, and we'll come back when Steve is done to talk about the meteor shower that's tonight that might turn into a meteor storm. So we're going to go, Marcy and I are going to go away for a second, and Dave's going to stay, talk to Steve.
And we're going to need some slides, Debbie, so don't forget.
Hi.
Steve.
Hi.
Hey, welcome. Welcome to the show. Is it good morning or good afternoon for you, wherever you are? Is it good evening someplace?
It's good afternoon for me. Thank you.
Good afternoon, Steve. Okay, so here is the first of your gorgeous images of Comet C12 2013, US 10 Catalina from December of 2015. And you've got a two-tailer here. Tell us about it.
Well, so all comets actually have two tails. The question is, can you see them? Right? It's got the dust tail, and that's what causes meteor showers. That's when the Earth passes through the dust. Kind of like from Charlie Brown with the Pigpen walking around leaving his dust trail behind. So does the comet, and then the Earth passes through it, and these little particles become meteors and shooting stars. And the ion tail, which is the other tail, is the one that's being blown out from the sun's solar wind and solar radiation, ionizing, whatever is ionizable on a comet. So like you were saying, the green, this diatomic carbon and cyanogen, and all these things can ionize. And so if this comet's in the right place, you get to see the two tails very distinctly.
Right.
But sometimes they're on top of each other, and you can't distinguish one from another. So this was my first two-tailed comet that I've imaged. So I've imaged 55 comets. So people think I'm an expert because of that, and that's not true. It just means I could have done something wrong 55 times also. But
well, you got this. Why is this image black and reverse?
Okay. So I have the other version of this image, but I like this one better because there's something about the human eye that lets you see fainter details when you reverse them. And this is why you see a lot of professional astronomical images and photographic plates from back when, that they would do it this way because your eye can pick up the faintest portions. It's just a human eye thing, the way we like to see colors and contrast. So a white background with dark details is easier for the eye to see. But I do have the regular version of it. But this one really shows how long that ion tail is, which is coming out way to the upper right in that image.
So that's pointing away from the sun. When we're talking about the ion trail of a comet, it is the ions. The solar wind is blowing particles off of the head of the comet. Comet. I'm suddenly not able to speak. Off of the head of the comet, away from the sun directly. But the other tail, the dust tail, follows where the comet has been, and that's why the two don't always point in the same direction. I think that's
that's my understanding as well. So
that, and those trails are actually detectable. I understand. David Chandler did a paper on that years and years ago. Anyway, Neowise here. We're looking at, what are we seeing now, Steve?
So Neowise, I deliberately did this one because it's analogous to what we might see with Tashunishan and Atlas comet A3. So I got Neowise in the morning, just like this present comet is, and it was
Beautiful.
Camera lens photographable, also naked eye visible just barely. But the evening for us is when it really performed because it was starting to move further from the sun. So it might have been getting fainter because of that, but moving into a darker background sky, which had the effect of it seeming brighter. And this is when you can use real photographic equipment. Like, so this picture on the right is using a telescope with tracking and guiding, long exposures. And you can just start to see on the left there a little blue ion tail separating from the dust tail sort of down the middle. So this is the first indication of an ion tail. It's sort of coming up, just to the left of the more gray part. There's a bluish ion tail forming. So I think A3 is going to be the same. I think it's going to get dimmer, but it's going to be more photographable with better equipment because of having the dark background sky as it moves away from the sun. So not as exciting as naked eye visible, but exciting to photographers because if you've got the right equipment, you can start revealing, long dust tails.
Let's talk about equipment for a second. I assume you shot. Now you said one was taken through a telescope. I assume, was that a DSLR attached to a telescope?
No. So the one with the telescope, the one that shows the more details and stuff, is a cooled astronomy camera. A dedicated astronomy camera that gets cooled to -10 or -15 Celsius on a mount that's tracking with a guide scope that's locking on a star to keep every image the same. And these are probably like 5-minute exposures, and then they're stacked. There's a process called aligning and stacking where you actually align up one image to the other, and then you kind of add them together. It's sort of a statistical way of adding, and that's what allows you to bring out these faint details. Yeah. And the picture on the left is me.
The contrast is really what matters here.
Right. The contrast is what matters. And so even though it's not as visible to the naked eye, the contrast allows these long exposures with the telescope to start bringing out way more details than your eye could ever see live.
Which is why the The image on the right there is so much more pronounced.
Right. So the thing is with the human eye is it's like a live video camera. You can't add things together, whereas digitally
No.
you can add the numbers from each picture to another, and you can get hours worth of data. It's like adding. A friend of mine says like adding water to a bucket. You can keep adding light to this bucket and just keep bringing out more and more detail. Whereas
That's
live,
a good analogy.
your eyes, you get what you get, with your eyes. And the
Yeah.
picture on the left is more what a naked eye view might be like, but it's still using a camera. But it's a short, like 5 or 10 second single exposure with a regular camera on a fixed tripod with a camera lens.
Now, could you do that with if we had the appropriate Comet? Could you do that with a cell phone?
Sure. Nowadays, like an iPhone 12, 13, 14, 15, 16 is as good as my Canon. I mean, the sensors that are in the new iPhones and the new some of these new Android phones, like the Galaxy and the Pixel and all that stuff. These are really good sensors. They're high sensitivity. You can do long exposures on them now, up to 30 seconds. So yeah, a cell phone will do a good job if you can hold it steady or have a tripod for it. The trick is holding it steady.
So yeah. As a matter of fact, a tripod is a great way to go. They're cheap and available.
Yeah.
All right, you got another slide. Here we go. Now we are looking here at A3.
This is
the
A3
one
in the morning, and it's very similar looking as Neowise was in the morning. So extrapolating what happened with Neowise, I think in the evening we should be able to get similar views as Neowise gave us, which is one of my best and favorite comets was Neowise. At least in modern times, maybe we had Comet West in the 70s, and we had Hyakutake and
that one I don't remember.
But this I think this comet looking the way it does now is the way Neowise looked in the morning, and it seems like this is persistent for comets, that they're really good southern hemisphere comets, then they become northern hemisphere in the morning, and then they become northern hemisphere in the evening, and if you get them timed just right, it seems like they become good evening comets. So I think this comet has the potential, I'm not making any predictions, but I think it has the potential to be a good evening comet for a couple of weeks, and probably peaking around like the 13th, 14th, 15th. Somebody showed the picture before with it next to Venus. That's about when it's going to start peaking for us, I think, is when it's near Venus, and then it'll keep moving further from the sun. It'll keep getting fainter, but it'll keep going into darker and darker portions of the sky, so that with better equipment, you can really capture some details. So that's my hope.
Wow. Hey, Stephen, thanks. Thank you so much for joining us and sharing with us. Speaking of sharing with us and sharing with our viewers, you are a poster at our EarthSky community photos. You share your photos there. Do you like that? Is that fun? Why are you doing that? Okay, so that's this is where I get to show off my stuff, and everyone gets to see it. This is a big deal. It is. I said it's a choice of being rich or famous. I'll take famous any day. I just posted yesterday my aurora shots on community, and I'm seeing other people are posting their aurora shots, so we all get to share on EarthSky community photos. So it's a great place to share what you've experienced, on the Earth and in the sky. So this is a fun thing. One Earth, one sky, and EarthSky. Yep. Steve, thank you again so much for bringing your expertise and your beautiful images, and not a prediction, but all signs point towards a beautiful comet. So we'll keep our fingers crossed and our eyes peeled. Okay. All right. Thanks. Dave. Appreciate it. Bye-bye. Yep. We'll see you next time. Yep. All right. Why don't we there's Marcy and there's Debbie. We got them. That was easy. I didn't even have to say it. They just popped right up. Okay. Hey, I see we've got Nightfall Northwest overhead and the Dracos. We're looking to the north. Oh, and there's the Little Dipper and the Big Dipper and Arcturus, the bear. All right, why don't you guys tell us what we're looking at? And I'll shut up for a while. Everybody will like that. Marcy, what are we looking at?
All right, this is the radiant spot to look at in the general area to watch for the meteors for the Draconids, which will be peaking later tonight. The little head of the dragon is pretty easy to spot even in the city. It's not super bright, but it's about as bright as some of the Big Dipper stars. So just look at that general area of the sky, and it's really unique because this radiant actually is already high in the sky as soon as it's getting dark. So you can actually watch meteors in the night instead of before dawn, which, for us that like to go to bed early, that's kind of nice.
So what we're looking at here is the radiant point. And the radiant point is near the stars Eltonin and Rostaban, which I love those two star names, Eltonin and Rostaban.
Saw them live.
In the constellation Draco. But you don't need to know where these stars are to see a meteor, right?
Right. You can just really just kind of scan the whole sky, because basically they'll just be shooting out in every direction. So,
right.
Just basically look to at nightfall, look to your north or northeast, and just kind of watch that area of the sky. And under good conditions, which we will have tonight, there's only a crescent moon out, so it shouldn't be interfering with watching for meteor shower. Just scan the sky watching, and you can see maybe up to 10 Draconids in an hour. And we did get a tip from the American Meteor Society that there could be an outburst tonight at roughly 1:30 to 2 Central Time. And it would be very brief. So an outburst, you could see hundreds and maybe even luckily thousands if you're super lucky, in a brief period of time. So, you never know. It's unpredictable.
So what's going on to cause that outburst? What's happening there?
Well, I believe you do have a slide ready for that, Debbie, but
I do. There it is.
The comet is fairly close to us here in 2024. And often these outbursts with the Draconids does occur when the comet is near us.
So right. And this slide is showing, if you can look along the bottom, you can see January 2023, July 2023. It's just going, it's a time. It's moving. The horizontal axis is time. And the vertical axis is the nearness of the comet. So in January of 2025, the comet's going to be at its closest, approximately. So we're here in October, so we're pretty close to where the comet is going to be closest. So Robert Lunsford of the American Meteor Society told us that either this year for the Draconids or next year for the Draconids, we might get a meteor storm. And we don't know if it's going to be this year or next year or at all, because you never know. But it could be. And next year, there's going to be a full moon. This year, the moon is in a good place. Next year, it won't be. So tonight is when this shower happens. So this is a really good night to go out into the country and to try to see, a meteor shower, a brief storm.
Absolutely. I would say about aurora, comets, and meteor showers, you never know what you're going to see, but you don't see anything if you don't go look, right?
Isn't that for sure?
That is so true. So you guys, and there's only one more thing that's cool about this about this meteor shower, and that is most meteor showers are named for the constellation that they appear to radiate from. So the Draconids radiate from the constellation Draco, and so they're called the Draconids, or Marcy, I think you called them the Draconids. So people in astronomy pronounce things all kinds of different ways. There's no right answer there. You can say it however you want.
We don't know how it's properly pronounced. You go right ahead.
Right, we don't know. You can call it whatever you want. But one thing that's different about this meteor shower is that sometimes people call it by the name of its comet, which is Comet 21P Jacobini-Zinner. So some people call this meteor shower the Draconids. And in fact, I learned it 50 years ago as the Draconids. So I always tended to call it that. And now everybody calls it the Draconids. So we were just talking about that last Thursday with Michelle Coopers of the Hera mission, which just launched this morning, because Hera is the follow-up to the DART mission, which impacted the asteroid moon Dimorphos in 2022. And when it did that, it created a human-made meteor shower. And that meteor shower isn't coming this year, but it may come in 2029, that we may see the first ever human-made meteor shower. And someone asked, what will they call it? And Michel, who is a project scientist for Hera, said he didn't know if they would name it for Dimorphos, in which case it would be the Dimorphids, or if they would name it for the constellation from which it'll appear to radiate, which is the constellation Indus in the southern hemisphere. So we don't know what they're going to call that human-made meteor shower in the year 2029, but that's ahead.
Yeah, those would be the Inoids if they go that way.
Oh gosh, let's hope they call it Dimorphids. I'll never be able to pronounce that.
I know. He even has an accented U over the E in the end there. So yeah, it's a mouthful.
We'll hear like 50 different pronunciations of that. So.
Oh yes, nobody but yeah.
Okay, so
that's it.
Yes, so that is it. So we're EarthSky. I've been speaking with Marcy Curran, the voice of the night sky at EarthSky, and David Dallion, who knows something about everything.
Apparently.
So, somehow. And we've been talking about the two bright comets that might be visible in October skies. Don't forget to watch for the Draconid meteor shower tonight. So those outbursts that we were talking about are predicted for between 6:30 and 7 UTC tomorrow morning. And the time on your clock is going to be a little different depending on where you live. So you can translate from UTC 6:30, between 6:30 and 7 UTC. You can translate from that, or you can translate from Central Time. In Central Time, it would be 1:30 to 2 a.m. tomorrow morning. But for Marcy, it's going to be closer to midnight. For Dave, Marcy's in Wyoming. For Dave in California, it's going to be late evening when you might see those outbursts. So lucky you.
Yes, lucky me.
Okay.
My dog, and get my chair and head out into the country.
Yes, you must. Okay, so we will be back at this same time on Friday, if not before, with our sun news of the week. One Earth, one sky, EarthSky.